In a previous video, we talked about linear equations. All through that video, we introduced what a linear equation was, and we also defined what a polynomial was through equations of single variables. A single variable equation is an equation with only one variable to deal with. So in the form of like 3x plus 1 is equal to 2, which is one that we dealt with in the last video. There's one variable that we want to see how it changes. We also defined what set notation was. These are also called solution sets, and those are the brackets. And I forgot to mention, so we'll go a little more in depth of this when we talk about space, but basically what's going on is we're in one-dimensional space, and what this is the number line that we're all used to looking at with 0 here. And any numbers that we end up in these brackets is going to end up on this number line. So if we get one of those brackets, it'll be 1 here. And we just plot it with a point. We just put a dot there. If b's in there, b being a number or a negative b, it's going to be in there. If those are in the brackets, it's going to be in there. And this is an important rule when we talk about interval notation coming up in a couple videos. But that's what a set really means. I apologize if that was not clear in the last video. Then we also did some examples of solving these linear equations. We're going to do some more involved equations that just take more steps to do, but let's get into it. For our first example, we have 2x minus 8 plus 40 is equal to 13 minus 3x minus 3. And like before, our goal is to isolate our single variable by getting it to one side and just numbers on another. So we're going to combine like terms on both sides, and we have numbers in common on this side. So 2x minus 8x, that's going to be 6x, plus 40 is going to be equal to 13 minus 3 is 10, 10 minus 3x. Now what we're going to do is we are going to then add 3x to both sides and subtract 40 from both sides. Alright. Using the stack method that I showed in the last video, basically what we do is when we're moving things to the other side, we do the opposite sign here. So instead of positive 40, we do minus 40. And on this side, instead of positive 3x, instead of minus 3x, we do positive 3x. And by the laws of algebra, whatever we do on one side, we must do to another. So let's just clean this up now. So 6x plus 3x, that's 9x. Plus 40 minus 40, that cancels out. And the equal sign comes down. 10 minus 40, that is minus 30. Minus 3x, positive 3x, those cancel out. So we want to get a single number of x, a single quantity of x. The way we do that is by dividing by 9 on both sides. 9 over 9x is going to be equal to minus 30 over 9. 9 and 9, they cancel out to become 1, give us a single variable of x, which is what we want. And if you look here, minus 30 and 9, they have 3 in common. We could take out a factor of 3, and that becomes 10 minus 10 over 3. So our final result is x is equal to minus 10 over 3. And in set notation, that's minus 10 over 3 in brackets. And if we were to draw this on a number line for the solution to this equation, this is our number line. You just draw a number line to put our 0. And minus 10 over 3, that's a little more than 3 to the left. So to the left of the zeros is minus 1, minus 2, minus 3, minus 4. And if you actually take a look, it's going to be in between minus 3 and minus 4, closer to minus 3. Almost to the middle, though. Right about there. Then we put a dot. Let's do another example. B. 5x is equal to 8 times the quantity of x plus 3. Now there's a couple of ways of tackling this problem. We could divide by 8 on both sides and isolate x's. We could do that. Or we could apply the distributive property. Either way is correct. Me personally, I feel like it's the same amount of steps involved. So let's do this. Divide. So actually, let's not divide. Let's do the distributive property this time around. We're going to, and I'll mention why in a bit. So we're going to distribute 8 by the distributive property. It says if we have a number times a quantity, it distributes, and that quantity is in parentheses or grouping symbols. It distributes across each term. So what this turns into is it turns into 5x, and it turns into the product of 8 times x, so 8x, plus 8 times 3, which is 24. Alright, we're going to subtract 8x from both sides. Alright, 5x minus 8x is minus 3x equals, comes down. The 8x's cancel out. It leaves us with 24 on that side. Divided by minus 3, x is equal to minus 8. So our final example for today will be 2 times the quantity of x minus 3 minus 17. Is going to be equal to 13 minus 3 times x plus 2. If you guys remember what we're doing in this, we are undoing the order of operations. Do not get these confused. This is here to trick you. Some people on this side would do 13 minus 3 first. Please do not do that. That's not the case, because we have this grouping, this 3 attached to this multiplication, this grouping symbol, this quantity and grouping symbols. So it's saying 3 times x plus 2, and it's not saying 13. Now, it's not saying 13 minus 3 in quantities times x plus 2. So please don't get that confused. So the only way we could do this is through distributing and combining like terms. So on this side, the 2 distributes evenly, and on this side, the 3 distributes itself across x and 2. And when I say it distributes evenly, what I mean is both pieces distribute the 2 in this side will distribute itself to the 2 and a minus 3x. So that gives us 2x minus 6 minus 17. It's going to be equal to 13 minus 3x, and minus 3 times 2 is minus 6. Okay, let's clean this up even further. Combining like terms on this side and this side, we get 2x Minus 6 minus 17. So minus number minus a minus gives us a bigger minus. 16 plus 17 is 23, so it'll be minus 23. It's going to be equal to, so 13 minus 6. That's going to be 7. 7 minus 3x. And let's add 3 to both sides. 3x to both sides. And let's add 23 to both sides. Alright. 2x and 5x. Sorry, 2x and 3x, sorry. Bad handwriting. That comes out to be 5x. Minus 23 plus 23, they cancel. 23 plus 7 is 30. And the 3x's cancel out. Divided by 5 on both sides, we get x is equal to 6. And some teachers will want you to keep it like that. Or in sets, that'll be just 6.